Alright, before we learn how to find limits of trig functions, we need to know about sandwich theorem, which is another name is Sui theorem. So think of sandwich theorem and think of trig functions. And we talked about this earlier, is that sometimes trig function can be tricky. So for example, it can be oscillate at that point. And we cannot really tell what is the limit at that point. So the sandwich theorem will help us to create what we call the upper function and the lower function, the one that we know how to find limit, to help us to determine what is the limit at C, which is this point right there, this point, that's at C. So we're going to give a name, so it's easier for us to see which function is which. So the top one, I would call that g of x. Okay. And the second one, which is the one in the middle, that's the function we call f of x. And the one on the bottom we call h of x. Excuse my handwriting. So for the sandwich theorem, what it says is that if h of x less than f of x less than g of x for all of x values in an open interval containing C except possibly a C itself, and if the limit at x approaching C for h of x is equal to L and limit x approaching C of g of x is also equal to L, then we can conclude that limit x approaching C of the function in the middle, which is f of x, is also equal to L. Alright, so let's do some example and to see how we use this theorem to find limit of trig function when it's oscillate or difficult for us to find limit at a certain point. So for example A, we have limit when x approaching 0, x squared times psi 1 over x. We want to prove that the limit as x approaching 0 is 0. So if you can take out your graphing calculator, and if you're going to graph this function, x squared psi 1 over x, we can see that it looks like something like this, somewhere in the middle, right? Now the problem is we cannot conclude that the limit is approaching 0 by just look at this graph. So what the goal, the idea is that we want to find the outer function and find the limit of those two so that we can prove, we can make a conclusion that because of the limit of these two outside of this one and the one on the bottom is equal to 0, therefore f of x, which is the one in the middle right here, is also equal to 0. So that's the goal. That's what we want to accomplish. So because the trig function is the one that oscillates right here at C, we kind of think in trig terms. So if you think about psi 1 over x, so we think of the outer function. Now, for the psi, if we're going to graph that, the highest values that psi would get to, think about the range, is that 1 and -1. So that's the range of that psi, of the trig function. So we look at this, the additional right here which we have is x squared. That's the function that we have. So think of inequality. If we have x squared, if we multiply x squared here, we're going to do the same for these two sides. So now I have negative x squared less than or equal to x squared sine 1 over x less than or equal to x squared. So what we're going to do about this is that we're going to find the limit. We call this one is h of x. The middle one is f of x, and this is g of x. So what we do is that we the goal is we're going to find the limit of h of x and g of x. Okay? We do know how to find limit of h of x because that's negative x squared. We know how to do that. So when x approaches 0 of negative x squared, the limit is 0 because we substitute in the 0 for negative x squared. That would be 0. Now we're going to find the limit for g of x, which is x squared. Again, the limit is also 0. Therefore, by the sandwich theorem, we can conclude that the limit at x approaching 0 for x squared sine 1 over x is also equal to 0. Alright, let's look at the next example, example B. So again, if you're just going to graph cosine of x over x, the problem with this one is that if I draw the graph, and then it's really difficult for you to see what is that approaching. It looks like something like this, right? We're not sure when x approaching infinity, is this really approaching 0 or what values it's approaching because it seems like it goes up and down. So again, same idea. We want to create an upper function and a lower function, find the limit of those two to draw the conclusion that cosine of x over x is approaching to the same values. So think of cosine function, right? Think of cosine. The range for cosine is also 1. It goes from negative 1 to 1. We're not going to have any values higher than that. So for this one, we see that's divided by x, because that's what we have. So you're going to do the same thing for the outside function. So now, if you look at this, this is h of x, this is f of x, this is g of x. We're going to find limit as x approaching infinity of negative 1 over x, which is negative 1 over infinity, which is, we know, 0. We're going to find limit x approaching infinity of 1 over x, which is g of x, is also 1 over infinity, which is 0. So because of the left side and the right side, the limit is 0, we can draw a conclusion by sandwich theorem, limit x approaching infinity of cosine of x over x is also 0. Alright, so that should be infinity, not 0. Okay. Alright, the one that I want you to give it a try is that you can try these practice 1, 2, and 3. Using the sandwich theorem, think about what would be the function, the main function, which function that you should start up with first. So that will be your practice that I want you to try those 3. We're going to take a question when we see you in class. So make sure that you have these 3 problems, try out step by step, and we'll take questions from you guys in class. Thank you. Enjoy your holiday. I'll see you Tuesday.